All right, what we're going to be doing today is talking about distance on a number line. And when we talk about distance on the number line, sometimes we're coming from a negative place, and we need to remember that distance is always positive. So you're going to see the use of some absolute value going on. I know we've been using that term a lot, so hopefully it feels very familiar to you at this point. Absolute value, remember, is how far is a point from 0? Well, 2 is 2 steps away from 0. Negative 6 is 6 steps away from 0, and they're both going to be positive because they're both distances. So the distance between any 2 points on the number line is the number of units between them. So just for this, from F to E, for instance, how many hops would it take to get there? Well, it's going to take me 6 hops to get back to 0, and then 2 more hops to get to E. So in that case, it would be 8. They're 8 points away from each other on the line. So between E and A, I can hop and go 1, 2, 3. They are 3 steps apart. A to F, I can do, they are 1, 2, 3, 4, 5 steps apart. F to B, they are 2 steps apart, and it doesn't matter which direction I go, if I go from A to F or F to A or F to B or B to F, it's still going to be the same number of hops. And then it asks about from C to B, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 steps between those 2 points. So counting on the number line like that will always work. So if you can make yourself a number line and make sure that you've divided it up correctly, and we'll talk about that here in a second, you can always use the number line and count the hops. It will always work. However, what is the downside of using a number line? Well, sometimes you have big numbers, and that would be a massive number line. Or sometimes you've got fractions and you need to find common denominators to figure out what you're going to divide up your fraction by, your decimal. So some drawbacks to the number line are big numbers, and then fractions and decimals can be a bit tricky on the number line. So looking at these examples above, try to come up with another way. Pause this and think to yourself, what is another way that I could do this without the number line? So hopefully what you've come up with is that the distance between any 2 points on the number line is the absolute value of their difference. So for instance, from E to A, E is at 2, A is at -1. So I'm set up absolute value. Remember, that is distance, not parentheses. I'm going to do 2, and the difference means I'm going to subtract, and I'm going to subtract a -1. So the next step in that is that keep, add, opposite. So I end up with what is the absolute value of 3, because I'm going to do 2 plus 1 here. So the distance between them is 3, and you're like, does that always work? Let's try this one. It's bigger. So from C to B, and I'm even going to flip it so that my negative is in front this time. So I'm going to do the absolute value of -8 minus 4. So I'm going from B to C here. So the first thing I'm going to tell myself is keep, add, opposite. So I'm like, I've got -8 plus -4, which is -12, and the absolute value or distance of that is indeed 12. Sorry, my paper got a little turned there. So when we come back down here, we're going to practice writing those subtraction expressions. So I'm going to go from E to A. So that's 2, and that's -1. So we did 2 minus a -1, and we found out that the solution was 3. let's take a look at A to C. So A is -1 and C is 4. So my subtraction expression is going to be -1 minus 4. So in order to solve that, I'm going to go keep, add, opposite. So I have the absolute value of -1 plus -4, which is -5, and the absolute value of that is 5. D to F, I've got 10, and F is -6, so 10 minus a -6. That keep, add the opposite, so keep, add, the opposite of -6 is +6, so I've got 10 plus 6, so the absolute value of 16, which is 16. B to F, so -8 to -6, so -8 minus a -6. Lots of negative signs in there. Remember, they just mean do the opposite. So the opposite of 8, I'm going to keep that. I'm going to add the opposite here, so I have -8 plus 6. Well, opposite signs, so I'm going to subtract them. So 8 minus 6 is 2, but the absolute value of -2 is 2. It's 2 spaces away from 0. We've got some more practice problems on the back here. See if we can apply this. So it says write a subtraction problem and solve the problem to find the distance between the points. Use the number lines to help you. So we've got C. So we're going to find the distance between point C and 5. Well, C is at 4. So for all of these, we're going to have 4 as one of our numbers. So the distance between C and 5, well, 4 minus 5, I can think, oh, that's -1, or I can do keep, add, opposite. Different signs, so I subtract. So there's 1 space between them, which we can clearly see on a number line. And it's nice that we can see these on a number line, but remember, we want to be able to use this with numbers that are bigger as well. So I'm going to do 4 minus 2. Well, that is 2, which means that they are 2 spaces apart, which once again we can clearly see. Moving on, we've got 4 minus a -4. Remember, keep, add, opposite. So they are 8 spaces away. The distance between C and 1 so they are 3 spaces away. Feel free to slow this down, pause it, go back, rewatch it if you think I'm moving too quickly. I'm just trying to make sure I get all of our problems in here before I run out of film. So keep, add, opposite. So they are 9 spaces away, which we could hop on our number line and see easily. We need to pause the video right now. And it says mark the point that is 4 less than 0. Label it A. Mark the point that is 3 more than 0. Label it B. And mark the point that is 7 more than -2. So 7 more than -2. So start at -2. And add up. C would be at 5. I want you to pause it, and I want you to try to find these distances and then turn it back on and check your work. So go ahead and pause that video again and check your work. So now that you've paused that and checked your answers, we're going to talk about these word problems at the bottom. So we're going to possibly draw a picture to represent the situation if necessary. So our picture that we draw, it might be a number line. It might actually be like a mountain. So it just depends what your picture might be. So we're going to draw a picture, we're going to write a subtraction problem, we're going to solve the problem. I always find that drawing pictures helps me a great deal when I'm trying to solve word problems like this. So Roman civilization began in 500 BC and ended in 476 AD. and we want to know how long did the Roman civilization last. Well, if I'm looking at a continuum on the number line, there is a year 0. Now, BC is back here, which means that it goes -1, -2, and it's going to go all the way back. So think of 509 BC as -509, which means that 476 AD, which is the side of the number line we are currently on, that is going to be a positive number. So to find the distance between them, I'm going to do 509 minus 476. So that's going to be my subtraction problem. Now remember, I'm going to add the opposite there. So add the opposite. These are both now negative, which means I'm going to add them together. And I am going to get a negative answer of 985. Check my addition there. I did mentally. And that means that there are 985 years that the Roman civilization lasted for. So 985 years was how long it lasted for. Impressive. Way to go, Romans. Mount Everest, the highest elevation in Asia, is 29,028 feet above sea level. So we're going to talk about sea level. Apparently I'm drawing the Red Sea. Ha. So the elevation of it is, the height, the top of it is at 29,028 feet. Since we are above sea level, that's a positive number. It then talks about the Dead Sea and the lowest elevation being below sea, 1,312 feet. Well, we think of that as a negative number, and we think of sea level here as being 0. So I need the distance between 29,028 feet, and I'm going to subtract that negative distance under the sea. So remember, I'm going to keep the first number, add the opposite. So I'm adding these two numbers. I want to go ahead and show this all lined up for addition to make sure that we all know how to line up our place value there. And I get 30,340. So that means that there are 30,340 feet between the top of Mount Everest and the bottom of the Dead Sea. Our last one is very similar to our topic 4 project for first quarter. So if you're having trouble with that, this is a good place to kind of look. It says the park is 5 miles west of the school, and Sarah lives 2 miles east of the school, and Mary lives 7 miles west of the school. Mary and Sarah are planning to go to the park on a Saturday afternoon. How far does Sarah have to ride her bike to get to the park? So we're going to put 0 on our number line. That's going to be the park, because we keep talking about 5 miles west and 2 miles east. So 5 miles west, 1, 2, 3, 4, 5. 5 miles west of the school. I'm sorry, this will be the school. 5 miles west of the schools, so sorry about that, is the park. And Sarah lives 2 miles east of the school. And Mary lives 7 miles west of the school. So Mary lives pretty close to the park. So our first question says, how far does Sarah have to ride her bike to get to the park? Well, Sarah has to go from all the way here to down here to get to the park. She has to go 2 minus a -5 is her distance. So poor Sarah has to travel 7 miles to get to the park. Now, how far does Mary have to walk to get to the park? Well, Mary just has to walk 2 miles while Sarah is biking 7 miles to get to the park. However, to make sure you feel free at any time to stop this and rewind it, relook at things, try things out, pause it, check it, and let me know if you have any questions.